Okay, so this is 9.2. No, 6. What are we even at? 7.2. Let me see which section this is. It's Unit 7. It's definitely 7. It's 2. Right? Yes. Okay, making sure before I write it up here. So this is 7.2 notes. And we are multiplying polynomials. Okay, so for the most simple type of multiplying polynomials you can have, it is going to be like we did on the warm-up. So it will be something like this, 3x squared times x squared minus 5x plus 2. So just to do one more example of this, whenever you have an expression right next to those parentheses, it means that you're multiplying and you're going to have to distribute it. So you would start off by doing 3x squared times x squared. That's going to give you 3x to the 4th power. Then you would have 3x squared times negative 5x. So the 3 and the negative 5 is going to be negative 15. And I've got 2 x's here, 1 here. That's going to be x to the 3rd. And for the last one, I would do 3x squared times 2. That'll give me 6x squared. Any questions about that? Caitlin, let's put that computer away for now. You shouldn't need it. All right. Then let's look at what to do when we get something like this. All right, so we've got x plus 3 in parentheses times x minus 7. And you're going to do a lot of problems like this before it's all said and done. So if I want to multiply these together, I am going to have to distribute, but it's going to be a little bit more complicated than it was over here for example 1. You not multiply, you mean like the x times 3 right here? You can't just like combine like terms. So like you're talking like maybe multiply like x times x and get x squared and 3 times negative 7 and get negative 21. Can't do it. That would not give you the right answer. Can't take away the parentheses. So, there is. Still doesn't make a difference, though. What do you think, Evan?
So, we would multiply the x on the left by the x on the right and the negative 7. And then we would multiply the 3 on the left by the x on the right and the negative 7 on the right.
I think you were missing a piece. So, you're saying take this x and multiply it by this x here, which will give me x squared. That's good. All right, and then x, you can copy this down if you want, he's right. I think, unless I misunderstood what he was saying. x times negative 7 would give me negative 7x. So you have distributed the x, but you have not distributed the 3 yet. So we're going to take that 3, and we're going to do the same thing. I'll write it down here. We're going to do 3 times x, which will give me a plus 3x, and 3 times negative 7, which will give me negative 21. So we have to distribute, but we have to distribute twice. Okay? And then usually with these types of problems, it is going to mean that you, have some like terms that you need to combine. So you're going to have x squared. We got negative 7x and positive 3x is going to be a negative 4x minus 21. Now, I'm going to put something up here that if you had a really old math teacher, they would probably use this word. But I don't think too many of us use it anymore, but I'm going to throw it out there because if you end up getting a teacher somewhere down the line that's a little more old school, they will probably use this acronym here. So this only works when you're multiplying a binomial times a binomial, meaning there's 2 terms in the first parentheses and 2 terms in the second parentheses. And so FOIL stands for first, outer, inner, last. So, I know that whenever I learned how to do this, that my teacher taught us how to FOIL and would use it like a verb. They would say you just FOIL those out right there instead of saying to distribute, which is really what you're doing. They would call it FOILing. I don't use this a lot because it's really just distributing, and this only works in one case, whereas distributing works in all cases. But I'm throwing it out there just because I know a lot of teachers still do use this term. So whenever it says first, you're multiplying the first term in the first parentheses by the first term in the second parentheses. When it says outer, you're multiplying this outer term by the outside term over here. That was this one, right? Then you've got the inside terms, so that's this term times this term, and then the last terms, this is last, and this is last. So, if you ever hear a teacher tell you to FOIL something out, they just mean to distribute. That's what it means. I'm going to tell you to distribute. I just wanted to put that in here because I still hear a lot of teachers say that from time to time. I don't think any of our teachers here really use that phrase a lot. Mr. Brown might, I'm not sure. I don't think he does, though. I think he uses a box. All right, so questions? All right, let's try some more. The reason I don't like to teach FOIL is because FOIL does not work if you have a problem like I'm about to give you for example 3. So we've got 2x minus 5 times x squared plus 3x minus 8. So FOIL, first, outers, inners, last, does not work whenever you have 3 terms in one of your parentheses. So what you're doing is just what Evan told us to do. We're taking our 2x, we're multiplying it by the first term here, which is going to give us 2x to the third power. Then we multiply it by the next term, which is going to give us positive 6x squared. And then we multiply it by that last term, which is going to give us negative 16x. And then we would distribute the negative 5. So we would have negative 5 times x squared, which is negative 5x squared. We would multiply negative 5 times 3x, which would give us negative 15x. And then negative 5 times negative 8, which would give us positive 40. And then most of the time whenever you do this, you're going to have some like terms. So you've got this positive 6x squared and this negative 5x squared. Now I'm going to go ahead and write the 2x cubed first. Then you'll have a positive x squared. You got this negative 16x and the negative 15x, which will give me negative 31x, and then that plus 40 stays there on the end. And then none of these are like terms, so you cannot combine them any further. Questions? Is it making sense so far? Okay. I'm going to give you a couple to try on your own. Check with your neighbor, see if they're getting the same answer as you. Correct. All right, here are the answers. So you can check and see if you and your partner were right. I think. It is okay if you put it in a different order, but it is most of the time going to be in descending order like I have it put here. So you're usually going to see the highest exponent first, then the next, and the next, and the next. So this is, I would be in the habit of putting it in this order because it's how your answer keys are usually going to be written, and answer choices if it's multiple choice. But it's technically still the same.
I thought you added the powers, like if it was -2 and -12, I thought you would add those two.
Not when you're adding and subtracting. When you're adding and subtracting, so when you're multiplying, you add them together. So like whenever I multiply x times 4x squared, I have 1x here and 2 here, so I get 3. But that's only when you're multiplying. When you're just combining like terms, you do not add the exponents. I also did this second one a little bit different. This may be a strategy you want to try. The blue right here is where I multiplied and distributed that x. And then the red is where I distributed the -3. And rather than writing it out as like a long string, I lined everything up. So all my x squareds were together, my x's were together. This was over here on the end. That way I could just sort of add it straight down, which helps me organize my thought a little bit whenever I'm doing these problems. I'm going to give you one more option for organizing your thought as well. Whenever I do these problems, the two binomials times binomials, I can do these in my head usually. Maybe not this one because it's out of order, but if the x's are first on both of them, I can usually do these in my head. A lot of my pre-cal and above students can also do them in your head. You should not be able to do them in your head just yet. Please write them down. But you may eventually get to where you can even do these in your head. I cannot do ones like example 5 in my head, but I usually do work these out this way. I might could if like my life depended on it, but I would not want to do it that way. Okay? The next type that I'm about to show you gets really mixed up. And I like to use a special tool to help me with these problems. So this time we're going to do something like x squared plus 5x minus 10 times, let's do 3x squared minus 12x plus 2. Alright, so if you're doing this, it means you're going to have to distribute 3 times, which gets a little messy. So, and it's very easy to make minor mistakes that are going to make your answers wrong.
Why'd you look up right now?
I didn't mean to, but then you made a face whenever I looked in your direction, and I thought, oh yeah, this is going to be bad for Isabella, because she is the queen of minor mistakes. So this is a tool that I do actually use, and I'm going to show you how you can use it on the smaller problems if you like it. Okay? Because I think that Coach Brown, when he teaches this, teaches you guys to use a box. Miss Martin might use it some. I don't know if she uses it exclusively. I don't like the box for the easier problems. I feel like it's a waste of time drawing the extra box. But for these big problems, I like the box because it helps me organize my work. So what you're going to do for this is you're going to take one of these trinomials, it doesn't matter which one, and you're going to put it across the top. So I'm going to put here x squared, positive 5x, negative 10. And then I'm going to take the other one, and I'm going to put it along the side. So 3x squared, negative 12x, positive 2. Alright, so if you guys remember whenever you were in like 3rd grade, you had those multiplication charts and it had 1 through 12 on the top and 1 through 12 on the side, or maybe even 0 through 12. And if you want to know what 3 times 7 was, you found 3 here, you found 7 here, and you did this and found where it was at. This is how that works. So like for this first box right here, I would multiply 3x squared times x squared. And that would give me 3x to the 4th power. What you've really done there is you just distributed your x there. You don't have to have a box. You can just do it like I was doing the other problems. It's just going to be like a long string of numbers that's easy to get mixed up. So this helps you. You can't, it's going to be more than just those 3 numbers. You're going to have 9 numbers if you do it. Because next we'd have to do x squared times negative 12x. Well, look what will go in this negative box. X squared times negative 12x, which will give us negative 12x to the 3rd. And then if we distributed this here, we'd be doing x squared times positive 2, which would give me 2x squared. So multiplying that first column of your box is the same as distributing your x squared. That's why this is going to work. So then next you would be distributing that 5x. So you'd be doing 5x times 3x squared. 5x times 3x squared is what goes in this box. So it would give you 15x to the 3rd. Then you would have to do 5x times negative 12x. That's going to give you negative 60x squared. And then you would have to do 5x times 2, which will be 10x. And then the last thing you would have to do if you were doing this without the box, and if you want to do it without the box, that is fine as long as you can get the right answer every time. Negative 10 times 3x squared, see how we have 3x squared and that negative 10, that's going to give us negative 30x squared. We would do negative 10 times negative 12x, that's going to give us positive 120x, and then we do negative 10 times that 2, negative 10 times 2 will give us negative 20. Here's one of the things I really like about the box, is that with the box, if you'll look at your diagonals, here, let me get the highlighter for that. this diagonal right here, both of those are x to the third power. This diagonal right here, both of those are x squared. Or all three of those are x squared. This one here, those are just x. So your diagonals end up being the numbers you need to add together to combine your like terms. So it just helps you organize your thought a little bit. So the 3x to the fourth would be right here. Then we would have to combine negative 12x to the third and 15x to the third. That would give me positive 3x to the third. Then I've got negative 60, negative 30, and 2. So that's going to be negative 88 x squared. Right here I've got a positive 10 and a positive 120. So that's going to give me plus 130 x, and then that minus 20 goes there on the end. So this would be my answer. Now, the box is optional on that because you are still just distributing, right? That box just helps you distribute, so you don't have to do that. But if you would like to use it, I find it helpful because it keeps me from making as many mistakes. Because this is almost like putting 10 problems in one, because you got to multiply 9 different things together, and then you have to combine those like terms. So there's lots of places you can go wrong. Missing one negative, multiplying one thing incorrectly can throw your answer off on these. Okay, questions? Now I want to say that Coach Brown has his kids use the box even on simple problems. So let me show you how it would work. Now, I can tell you from looking at this problem that it's going to be 3x squared plus 19x minus 14. So, like, I can do that in my head, but I've had a lot of practice with working with this. So that is why I do not like to use the box, because I think it takes extra time that's unnecessary. But if you are a little bit confused by this and the box helps you, you are welcome to use it, because I would much rather you be a little bit slower and be correct than to be fast and wrong, like this. So if you use the box, again here, it's doing the same thing. You're taking 3x, you're distributing it. 3x times x gives us 3x squared, right? Then you do 3x times 7. Well, 3x times 7 will give you 21x. Then you would take the negative 2, you would distribute it, so you get negative 2x, and then you would distribute here, and you would get negative 14. So you would get the same numbers, whether you use the box or not. And then the numbers right here can combine. So you would have 3x squared plus 19x minus 14. So if you like using the box, you're welcome to use it. Okay, questions? All right, so this is pretty much it. I've got a worksheet that we're going to do. This worksheet is going to be classwork. I want you to try to get it done in class. Okay, I think you can if you work diligently. Then there will be a second worksheet that has more of the same types of problems, but they're all going to be like these special cases. And I want you to think of coming up with a shortcut rule for them. There's not really a shortcut rule for these, but for the second worksheet, there sort of is. So
Oh, no, we almost died today.
Oh, it's so fun.
Okay. We started suffocating.
It was really hot. It was like
really hot,
like
like
the
the
sun was shining directly on us and on
Started.
It was fun though.
Yeah.